Hey guys, welcome back. So in this video, we'll be discussing on the second problem of beams. So this problem has the simply supported beam with the central loading condition, which has two supporting factors with a hinge support acting at the two corners of the beam and force acting at the center of the beam. So we'll be modeling the structure by adding three key points. So these are the points and we'll be connecting them, then proceeding with the meshing and assigning loads as per the hinges and with the force acting along the downward direction of vertical support. So this is the cross section values we are given. So let's start the structural part in the ANSYS. So hey guys, welcome back. So let's start the structural part in the ANSYS window. Starting with the preferences, we'll select structural. In preprocessor, we'll be selecting the element type and add the beam 2D elastic 3. Click on OK and close it. Then we'll be defining the real constant. Going to real constants, add. So defining the real constants over here. So the area for the real constant is 5400, which is length, breadth into height. So I've discussed the parameters about the area, moment of inertia, and height detailedly about everything in the previous video. Please watch the previous video before watching this. So the area of moment of inertia. So the moment of inertia is given by length, breadth into height to the power of 3 by 12, which is 60 into 90 to the power of 3 by 12. And the height is 90 as per the given question. We'll just click on OK and close it. And now we'll be defining the material properties. Going to material properties, material library. Sorry, going to material properties and material models. In material model number 1, we'll be selecting the structural, linear, elastic, isotropic, and Young's modulus for this specific problem is given as 210 gigapascal, which is 210 E3, and the Poisson's ratio would be 0.3. Click on OK and just close it. And moving on to the modeling part, we'll be creating the key points. Going to modeling, create key points in active CS. So initially we'll be creating the first key point as 1 and initial coordinates would be 0, 0, 0 and apply it. So the second key point is along the x-axis, which is at the distance of 1000 mm, and click on apply. Then the third key point is somewhere around 2000. So we can just add another 1000 for the x-axis and click on OK. So the three key points has been added. We'll just connect them with the lines by going to lines, straight line. I'll just connect the first to second to third, and click on OK. So the lines and points has been created. We'll just go with the meshing part. Going to meshing part, just go to mesh attributes. Click on pick lines. Just pick this two lines. Click on OK. So the material number 1 and real constant 1 should be selected. Then just click on OK. Go to size controls, manual size, lines. So just click on all lines or pick lines. Anything works. And in this, the number of element division should be 5 and click on OK. So now after the division of line with 5 divisions, so next we'll be going to the mesh part finally. So in mesh, go to lines, inlines, go to pick all. So this completes the meshing part. You can just close the meshing. We'll be now heading towards assigning the loads. Going to loads, define loads, apply structural. So there are three types of loads over here. The first and third key point will be assigning the displacement load. So the third load will be assigned at the second key point, which is the force acting along the downward direction of y-axis. Let's start with the displacement on key points. Just select the first and third key point. Click on OK. So the degrees of freedom should be constrained along ux, uy, and rotation z-axis. So these three should be selected, and with the displacement value of 0 should be defined. After entering all this, just click on OK. And now we'll be going to assign the force along the key point, second key point. Just click on OK. So the force direction would be around the y-axis, and the value would be minus 4000, which is because it's acting towards downward. So the negative has been applied. So this should be the final structure. You can just verify going to solution, solve, and current list. So once we get the solution is done as a note, just close it, and now we are ready to go with the general post processor thing. So in general post processor, we'll be defining few tables. So these tables are necessary for obtaining the required results. I have already detailedly discussed about these tables, defining about the shear force diagram and bending moment diagram in my previous video. So you can just watch the previous video to have a clear knowledge on the SFD and BMD. So now I'll be creating the table, going to element table, define table. Here I'll add it. So the user table will be SFDI, and selecting by sequence norm and SMISC, comma 2. Apply it, and the second level would be SFDJ, and by sequence norm should be selected with SMISC, comma 8. Apply, and the BMD label should be defined with by sequence num and SMISC, comma 6, and just apply. Then going to BMDJ, then selecting by sequence num with SMISC, comma 12. So just clicking on OK. So these are the necessary labels and components we have declared. Just note them down, and we'll just close it. Now let's start by plotting the result. I'm going to plot results, counter plot, and nodal solution. End of solution, the displacement vector sum should be selected, and click on OK. So the DMX and SMX value can be noted down, and the diagram can be downloaded. Then going on with the element result. So going with the line element result. So in the node I and node J, we'll be assigning SFDI and SFDJ respectively. So node I should be chosen with SFDI, and the node J should be assigned with SFDJ. Clicking on OK. So this would be the shear force diagram, and you can just download it. And now we'll be getting the BMD and BMDI and BMDJ respectively. for node I and node J. So just clicking on OK, you just get the bending moment diagram. You can just download that as well. So at last we'll be listing the results by going to list results, model solution, dot solution, and the displacement vector sum. The values can be noted down, and then going to element table data. So in element table data, select the SFD and SFDij. Clicking on OK, we'll get the minimum maximum values. You can just copy that. Similarly, we can do it for VMDI and VMDJ by selecting the other two values. Clicking on OK, we'll get the minimum values and maximum values for them respectively. So at last, the final reaction solution can be obtained. Clicking on OK, the values will be displayed. You can just note it down and copy it. So this completes the second problem of beams. You can even animate this by going to plot controls, style, size and shape. Just enable the display of element, click on OK, and going to plot controls again. In animate, just go to deform shape. In items to be plotted, you just select the deformed plus undeformed. Clicking on OK, we'll get the animated modeling of the structure. So this completes the second problem entirely. Thank you for watching.